Let's discuss question number 2 from test 8. This is from engineering mechanics. Question number 2. A uniform rod of mass m and length L rotates in a horizontal plane with an angular velocity W. Well, it is printed W, but in a sense it has to be omega, about a vertical axis passing through one end. So you have a rod. Okay, let's say the mass is m, length is L, and about an end it is free to rotate. So it is free to rotate about this end. Okay, and there's a vertical axis. Okay, in the horizontal plane, the tension in the rod at a distance x from the x-axis. So at a distance x from the x-axis, okay, what is the tension in the rod? Okay, so if I consider the right hand side, the entire right hand side, okay, the right hand side has a length L minus x and the mass, well, the total mass m, because it's a uniform rod, the total mass m is distributed over the length L. Now for this right hand part, right side of this section L minus x, the mass will be m dash. Well, I can say that m dash by m, they vary in proportional to the lengths because area of cross section is constant. So m dash will be total mass into L minus x by L is the mass of this, and this, so if I consider this as a free body, this m dash will be acting at the center of this. So this length would be L minus x by 2, this length. So the CG will be acting for the right side part somewhere here. Now as it is rotating about this vertical axis, so any body which is rotating about an axis, well, all the points, it's a fixed axis rotation, right, about this vertical axis. So all the points move in a circle, and thereby CG, the CG moves in a circle, and whenever CG is moving in a circle, any body that is moving in a circle has two accelerations. One is your tangential acceleration, and other is normal acceleration. Well, the tangential acceleration alpha, well, tangential acceleration A is r alpha, and normal acceleration is r omega square. But this is from basics of engineering mechanics. Well, because it's moving with constant omega, I mean it's not given, and that's not necessary also, because tangential here is perpendicular to this plane, and so that's not needed. Now normal acceleration acts somewhere here, acts in this direction. Okay, so if I happen to draw a free body diagram of this, well, though I am taking more time in this, but then this is very important. Okay, so I've taken a, so I'm just drawing a free body diagram of this. The CG here acts here, so weight will be acting downwards, m dash g, and this part, the left part, will exert some tension, obviously, otherwise this the right hand side will move away. Why will it stay there? It has to, there has to be some tension that is exerted by the left part on the right part. So this tension is what I need. Okay, now this is the force diagram. The equivalent kinetic diagram, that is because of the motion, this body has tangential and normal acceleration. The normal acceleration inertia is MAN, and tangential acceleration inertia is perpendicular, which I am not representing here because I am going to just do the force balance in this plane. The perpendicular plane doesn't matter. So if I do a force balance along this axis, so minus T, okay, so well, how do I, so this is my free body diagram, and this is my kinetic diagram. Free body diagram, I represented all the forces. Kinetic diagram, I represented all the inertias which is based on the motion of the body. Okay, so free body diagram, well, so how do I write? I use Newton's law in any direction. So let's say in x direction, this is my x direction. All the forces provides, all the forces added up in a particular direction in free body diagram provides me max. So here it is, so I am just going to use this direction. So minus T, there are no other forces in the x direction, is equal to, the inertia is also in this direction, so minus MAN. So T is MAN, and so M is basically the mass of this, which is m dash. Remember, it's m dash, right? I'm just using for the right hand side body. So m dash in terms of m is m L minus x by L. AN is r omega square. Well, r is the distance of this from the axis, so this is r. So r would be your x plus your L minus x by 2, right? Because r is the distance of the CG from the rotational axis, so this is L plus x by 2. So r is, because an I'm going to write r omega square, so L plus x by 2 omega square. Omega is written as w here, so it is L minus x, L plus x is L square minus x by 2 L omega square. So in a sense I can write m omega square by 2 L square minus h square by L. So let's see. So this is the tension, and tension is towards, basically it's tension, it's pulling, it is this force that provides the necessary centripetal acceleration. Otherwise, if there is no tension, it will just fly away radially outwards. So going by this, the answer is D, though I have taken more time, but this problem will really help you understanding what happens when a body is moving in a circular motion. Okay, thank you.